Welcome to my lecture on the Chebyshev inequality. So Chebyshev's inequality is a statement about probability and the number of standard deviations from the mean. So for example, x minus mu is less than k times sigma has probability that is at least 1 minus 1 over k squared. Okay, and let's just do a quick example. Okay, so before I even get to the example, there's one more thing I'd like to say, which is just that this statement is true regardless of the distribution of x. Okay, and just one last thing, if I had to solve an inequality like x minus 2 is less than 3, I can just solve this normally, x minus 2 is less than 3, and get x is less than 5. Or there's another possibility, which is that minus x minus 2 is less than 3. And when we do that, okay, we're going to have to reverse the inequality. So that tells us that x minus 2, when I change the inequality, move the negative to the other side, that's negative 3. So x is greater than minus 1. And there's two solutions to be solved there. One is the plus of that, and one of them's the minus. So just keep that in mind. Okay. And if we had to look at this, like here's going to be 2, then there's a radius of, here's going to be negative 1, here's going to be 5, right? And notice that 2 lies right in the center there. So it goes 3 that way and 3 that way. Okay. So let me just give you a quick example. The price of stock has an average value of $25 and a standard deviation of $4. Here's going to be a couple of questions. Question 1 asks this: what is the minimum probability the price of stock has a value between $17 and $33. Okay, Question 2, what is an approximate range for the price of stock that it will trade between 75% of the time? Okay, and if I was to answer this question, let's answer the first one. Just note okay, so let's just note that Chebyshev's gonna say this: probability x minus mu is less than or equal to k sigma is at least 1 minus 1 over k squared. And I'm going to let k equal to 2. Okay, so I know that mu is equal to $25 and sigma is equal to $4. So probability, the price of stock x, so by the way, x is equal to price of stock, which no one knows its distribution. If you did, well, you'd be rich. X minus 25 is less than or equal to k, which is 2, times sigma, which is 4, is at least 1 minus 1 over 2 squared. Okay. Well, that says the probability x minus 25 is less than or equal to 2 times 4 is 8, is at least 1 minus 1/4. That's 75%. Okay, and if I had to undo this inequality, this would say minus 8 is greater than or equal to x minus 25. Less than or equal to plus 8. And that's 75% of the time. So I'm going to add the 25. And I think I'm going to get 25 minus 8, okay, is going to be 17. And less than 33, and that's 75% of the time. So we've answered both questions here. So the minimum probability the price of the stock is between $17 and $33 is 75%, and the interval that corresponds to 75% is the interval from 17 to 32. So 75% probability corresponds to the interval 17x to $33. So, and I should say minimum 75% probability, because it could be more. Okay, right? One thing that I made a little mistake with was this. It should be bigger than or equal to. Okay? Most of your problems correspond to tinkering with the value of k. Okay, and notice one more thing. Note, I could set 0.75 equal to 1 minus 1 over k squared and solve for k to get k equals 2. So that's one way of solving these types of problems. And that's really all there is to the Chebyshev inequality, unless you want to prove it. But I just wanted to play with what the theorem says in your textbook. Okay, thank you.